Hey guys, it's Doug again. Here's your week 6 MyStatLab problem 7 example. A company compiles data on a variety of issues in education. In 2003, the company reported that the national college freshman to sophomore retention rate was 71%. Consider colleges with freshman classes of 450 students. Use the 68, 95, 99.7 rule to describe the sampling distribution model for the percentage of students expected to return for their sophomore years. Do you think the appropriate conditions are met? So let's take a look at this and see if we can work out what we need to answer this problem. The distribution of the proportion is a normal distribution with mean p hat equaling p and the standard deviation SD p hat being the square root of P times Q over N. So we need to do a little bit of math. We need to know P, Q, and N to start with. Well, we already know what P is. The proportion is given to us. It was a rate of 71%. So that means P will be 0.71. Since that's the case, now we need to know Q. Well, Q is simply 1 minus P. So let's use our Excel math here. We'll say equals 1 minus, hit enter, and there we have it. Q will be 0.29. So now we need to know what the standard deviation of P hat is. So we know that we need to find the square root of P times Q over N. So let's put a formula here and do that. So we need to start off with square root. So I'll say equals and start typing square root, and there it is right there. Click on that and it gives us some parentheses. I'm actually going to add another one here to make sure that our formula works right. And then we're going to say P times Q, so P times Q, close those parentheses, divided by an N. What is N? N is our number of students here. In this case, we're looking at 450 as the total there. So 450. Our brackets are closed. So all we have to do now is hit enter. And there we have 0.021391. So we're going to round that to 0.021, and that will be our standard deviation of P hat. So now we have what we need to come up with our limits for each one of our pieces of the rules, the 68%, the 95%, and the 99.7%. And this rule states that 68% of the area lies within the mean of P hat, or 0.71, plus or minus 1 standard deviation, which we just calculated at 0.021. The 95% falls within 2 standard deviations, and 99.7% of this will fall within 3 standard deviations. So let's go ahead and get our lower limit for the 68%. So in this case, we know we start all of our Excel math with equals, and our our mean P hat is 0.71. So we'll say 0.71 minus our standard deviation of P hat, 0.021, enter, and there is our lower limit, 0.689, 68.9. Same thing here for our upper limit. Now we're going to take equals P plus our standard deviation, enter, and there's the upper, 0.731. Now let's go ahead and go to Our 95%, now we need 2 standard deviations. So we'll say equals P minus, for the lower limit, but now we need to say 2 times that standard deviation. Hit enter, and there is our lower limit for 95% at 0.668. Same thing here, we're going to take proportion plus 2 times standard deviation, and there's the upper limit for the second part, or the 95% at 0.752. One more time now. Now we're going to go 3 standard deviations, so equals 0.71 minus 3 times our standard deviation. Doesn't Excel make this easy? So the lower limit is now, the bottom's 0.647. Same here, equals 0.71 plus 3 times that standard deviation. And there we have it. Our upper and lower limit for all 3 standard deviations. With 68% being 0.689 to 0.731, all the way up to our 99.7, which is 3 standard deviations away. We get 0.647 for the lower limit, 0.773 for the upper limit. So let's see what that's going to look like. I think you have to pick a graph. So I'm going to scroll here, and I put this in there. You can see our lower limit for all 3 at 0.64, the upper at 0.78, 0.71 is the mean there, the proportion, which is the middle of our curve. We can go back and check 0.647, 0.773, which is approximately where we are there at 6.4 to 0.78. So there you have it. That's what your graph would look like, your bell curve would look like, with each one of those standard deviations and a mean of 0.71. So the final part, do you think the appropriate conditions are met? Well, the first one is randomization. All right, the sampling method has to be at least not biased, and the sample has to be representative of the population. The randomization condition may not be satisfied because the sample may not be representative of the population. Since only colleges with 450 freshmen are considered, then probably this sample is not random. Well, how about the other 2 rules, the 10% rule? This condition is that the sample must be no larger than 10% of the population. Well, if our sample was 450, we would have to think that there are more than 4,500 college students. So we can say that the part 2, the 10% rule, has been met. Now, how about the 10% success failure? Well, to do that, we have to say N times P and N times Q and make sure each one of those is over 450. So let's do that just to make sure. So equals N times P. So 319, well over the 10. And also N times Q. So here again, equals N times Q. Enter, and that's 130. And I know right here it says 10% success failure, but it should be just 10 successes and failures. There we go. And of course 319 and 130 are way over 10. So 2 of our 3 rules are met, but we cannot say that this the randomization condition is met because we only took colleges that have 450 freshmen. So there you have it. There is your MyStatLab problem 7 from week 6. There's your example, guys. Hope it helps.